Hello everyone. In this video we'll learn the third category of finite automata without output. It is epsilon Ndfa. So epsilon Ndfa and Ndfa both are similar. The only difference is epsilon symbol. So epsilon symbol is especially added to the epsilon Ndfa category. So here if you observe, the definition of Ndfa is consisting of 5 tuples. The 5 tuples are capital Q, sigma, delta, Q naught and capital F. Okay, and you already know that capital Q is set of state, finite set of states. Okay, then sigma is input alphabet, Q naught is initial state, capital F is final states, and capital F is properly a proper subset of capital Q. Means capital F is the proper subset of finite set of states. And if we talk about the delta, which is transition function, in transition function it is slightly different from the transition function of non-deterministic finite automata. In non-deterministic finite automata, the transition function is q cross sigma tends to 2 raised to the power q. Okay, means if you are present at some state q and you see some input alphabet sigma, you will go to your chances of going to various other states will increase, and the chances will be 2 raised to the power q. Okay, but in epsilon and Ndfa we have added one more symbol epsilon to the input alphabet. We have added one more symbol epsilon to the input alphabet sigma. Now it is read as q cross sigma union epsilon, q cross sigma union epsilon tends to 2 raised to the power q. Okay, or q cross sigma union epsilon derives 2 raised to the power q. Okay, and the other thing is same. Set of state is same, initial state is same, final state is same. Okay, so from this we can clearly say that every Ndfa non-deterministic finite automata is epsilon non-deterministic finite automata, because epsilon Ndfa contains the Ndfa portion, and we already learned that every non-deterministic finite automata is converted to deterministic finite automata. So if I talk about the whole classification, finite automata without output, then one is DFA, other one is Ndfa, and the last one is epsilon Ndfa. Okay, we already learned that DFA and Ndfa are equivalent in power. Okay, and every epsilon Ndfa can be converted to Ndfa. Okay, that means if you convert epsilon Ndfa to Ndfa, you can also convert this Ndfa to DFA. So it derives a result called the equivalency of finite automata without output. Means DFA, Ndfa and epsilon Ndfa, all these three finite automata machines are equivalent in power. This is very important. You have to note it down. All the finite automata without output are equivalent in power. Okay, so please note it down. This is very important. All the finite automata are equivalent in power. Okay. Now how we can convert epsilon ndfa to ndfa? So for that, let's take an example of epsilon ndfa, and I will show you how the epsilon ndfa will be converted to ndfa. So what is epsilon? Epsilon is special symbol which depicts that there is no move, or there is no transition defined for from one state to other state whenever you see epsilon. Okay. So let's take an example. A is the initial state, and then B another state, C another state, and D final state. These are the 4 states available in epsilon and ndfa, and A will read 0 and goes to A itself. If I take a epsilon move from A, then I will go to the state B. Similarly, B will go to C by reading 0 input alphabet, and C will go to B by reading 1 input alphabet. B will go to D by reading epsilon symbol, and D will accept any number of 0 and 1 on the D itself. Okay. So here one special property called epsilon closure property, one special property called closure property is used. Closure property is used to convert every epsilon ndfa into ndfa. So what is closure property? If you present at some state, let's say A, and by reading the input epsilon, how many number of states you will go to that how many number of states you will go to the other state by reading just epsilon symbol? Means, let's say you are state on A and read some 0 input alphabet, and if you see epsilon, then I will take this transition, and then after I will take the epsilon move. Okay, I will take the epsilon move. So A will go to B by reading epsilon, and B will go to D by reading just epsilon. So it means that A will go to B as well as A will go to D by just reading epsilon symbols. Okay, but it does not go to the state capital C, because capital C does not any epsilon moves. Okay, so this is the introduction of epsilon and ndfa. In the next video, we will see how to convert this transition diagram of epsilon and ndfa into ndfa transition diagram.